Okay, so this is the example program from chapter 2 in which we demonstrate equality operators, relational operators available in C. So we have two lines, two printf statements giving instructions to the user to enter two integers. We're defining two integers num1 and num2, then using a single scanf statement to read in two integers separated by a space into num1 and num2, and then we have 6 if statements, and in each one we check one relationship between num1 and num2. And the first one we check for equality, the second one for num1 not being equal to num2, then num1 being less than num2, num1 being greater than num2, then less than or equal to, and greater than or equal to relationships. So let me run this and let me first recreate the 3 examples that basically together demonstrate all of the if statements that they're working. So let me enter 3 and 7. So 3 is not equal to 7, 3 is less than 7, 3 is less than or equal to 7. Another one, 22 and 12. 22 is not equal to 12, 22 is greater than 12, 22 is greater than or equal to 12. And one more time to demonstrate that we can also hit the equality condition. 7 is equal to 7, 7 is less than or equal to 7, 7 is greater than or equal to 7. So you have also seen that the code, at least the codes that we'll be writing, they execute quite quickly. You cannot really follow what's happening step by step on each line. So I told you that I'd be introducing you gradually to different features of Visual Studio that you can use to debug your program. So today I'll introduce you to one of those features, actually 2 technically. The first one is called a breakpoint. So what you can do is you can pick a line in your code. So in my example, let me just pick this one over here, line 6, and you can hit the F9 button on your keyboard, the F9 key, and you can see that this has added a red circle over here on that line. This is called a breakpoint. Now with this breakpoint added to this line, what will happen is next time I run this program with the F5 key or the run button up here, the program will run like it did before, but when it reaches this line where I put the breakpoint, it will pause, not permanently stop, not exit, just pause. From there onwards, I can then either continue running by hitting the run key, the F5 key again, or I can then decide to slow down execution of my code line by line. And this is called stepping through code, and I'm going to do that with the F10 key. Now all of these features are found under the debug menu in Visual Studio. So here, toggle breakpoint. So that's basically, I just added the breakpoint. I can just like that, I can go to this line, hit the F9 key again to remove the breakpoint, on and off. And you can do that for any line really. And the next feature that I'm talking about is stepping through the code. So this is that step over feature mapped to the F10 key on your keyboard. So instead of going into the menu up here for each to execute one line of code, instead I'm going to use the F10 button, the F10 key on my keyboard. So let me show you what that looks like. So my breakpoint is already added over here, I'm going to hit the F5 key now, and there you go. See that yellow arrow? That will always show me where in the code we are right now. So right now execution is paused, and I want to take a look at the console. So the first printf statement has executed. The second one, the one that prints the relationship they satisfy, that hasn't executed yet. I'm on this line, and it's basically the compiler is waiting for me to specify when to run this instruction, and I'm going to do that with the F10 key. I'm going to hit the F10 key once. There you go, and look on the console. The second line has now been printed. And so these are just definitions, creating integer num1, integer num2, and look down here in this window. It's showing num1 and num2 and what type of variables they are and what's stored in them right now. So right now they contain what we should consider garbage. We don't know what they contain. They contain whatever is in that memory location from before. We haven't written anything to num1, num2. And here right above that, ampersand num1, ampersand num2, these are the addresses of num1 and num2 in your computer's memory right now. Okay, so so you can see the values of the variables. When they change, you can see them changing right here in this window. Very neat. So let me step through this. So the next step is to run the scanf function, and now this requires keyboard input, so that's why context has we have automatically activated. It has Visual Studio has switched context to the console window, and I'm going to enter 7 and 7, the last example that we ran. I'm gonna hit enter. There you go. And now I am on line 13, the first if statement, on which we're going to check for equality. I'm going to hit the F10 key, and given that I've entered 7 and 7, and which you can by the way see down here, 7 and 7, the values of num1 and num2. Okay, so I'm going to hit the F10 key, and since both num1 and num2 are equal, they contain the same values. This means next line to execute should be the lines of code inside this if block. So I'm hitting F10, and there you go. Because num1 is equal to num2, we are now on line 14. And going to hit F10 again. That takes us to the next if statement. Over here we check whether num1 is not equal to num2. That is a condition that is false for the given input, and which means we should now jump from line 17 over line 18 and directly to line 21. Let's see if that happens. There you go. And num1 less than num2 is false, which means we'll skip over line 22 and jump directly to line 25, the next line of code. And num1 greater than num2, also false, so we'll jump over the code in the if block, which is just line 26, and we'll end up on the next if statement on line 29. If I hit the F10 key again, here you go, this condition will evaluate to true, which means this printf statement on line 30 should execute. There you go. And just to keep track, you can see here on the console that is playing out just the way we are expecting it to. Going to hit F10 again. This is also true, and that's the end of the program. That's it. We're back, and here's the console window. You can see the 3 lines of output from the 3 if statements whose conditions evaluated to true. So That's another debugging tool in your arsenal. Let me also show you one more thing. So we're already familiar with the basic data types in C. Something that was added later on is, let me leave all of this as it is. I'm going to comment that out. And what you can also do is, there's kind of a it's not non-native data type. You'll learn later on where this came from. But when you know that you're going to need a variable that will only or should only take on binary values, true or false, 0 or 1. C does have kind of a disguised integer called a Boolean, or abbreviated as bool, like this, that you can use. So let's say I want to create a Boolean variable, calling it A, and I can assign to A different values, which I'm also going to print out to show you what they look like. So you can assign to A the value 0, for example. That'll work. You can assign it the value 1, of course. You can assign it the value true. And you see this is highlighted in blue because it's being recognized as a keyword, as an entity. Okay, and finally, let me also show you what happens if I assign the value 100 to A. Okay, and let me print these out. Okay, so printf, to print these out as decimal numbers. So I'm going to print out A over here. Oh, let me add a new line character over here. There you go. So I'm assigning A 0, 1, true, false, and 100. And after each assignment, I'm printing out the value of A as a decimal number. Let's see what that looks like. There you go. And the interesting thing to see, so the first 0, when I assign it a 0, not surprising. When I assign it a 1, I see a 1, not surprising. The third assignment is when I assign true to A. That turns into a 1, fine. When I assign it a false, that of course turns into a 0. I mentioned that in the theory lecture. But the interesting case is the last one. When I assign 100 to A and print out the value of A, it shows as 1. So basically any non-zero value will show as a 1. So that's when you're absolutely sure what you need is just a Boolean variable. You can simply use bool, and like I said, it's underneath that you have an integer, but if you try to assign it a non-zero value, that non-zero value maps to a 1.